Okay, so let's go over the 12-7 master to see if you're understanding this fundamental theorem of similarity. Okay. If Alice takes a pill that makes her 6 times as large, how tall would Alice be? So height is one-dimensional. Her original height is 5 feet tall. If she's 6 times as large, so that's 5 times 6 is 30 feet tall. How much would Alice weigh? Weight is 3-dimensional. So we're going to use a k cubed value. So k is 6. So we're going to take her weight, which is 100 pounds. We're going to multiply it by 6 cubed. She would weigh 21,600 pounds. How much orange juice would she drink? Give your answer to the nearest gallon. So 8 ounces, this is volume again. So we'll take 8 times 6 cubed will give us ounces. Okay, and then there's 128 ounces in a gallon. So it says round to the nearest gallon would be 14 gallons. Okay, number 2, if she takes a pill that makes her 1/6 as large. So now K is 1/6. How tall would she be? Well, she would be 5/6 of a foot. 5 feet times 1/6. And if you did that in inches, that would be 10 inches tall. All right, and then how much would she weigh? So now we're going to take the 100 pounds, we're going to multiply it by 1/6 cubed, because weight again is 3-dimensional. We get she would weigh 0.46 pounds. And then how much orange juice would she drink every day? So obviously this is really small. I mean, you think a baby's born, weighs 7, 8, 9 pounds. She's weighing less than a half a pound. That's itty bitty. Of course, she's only 10 inches. So that's not very big either. Orange juice, 8 times 1/6 cubed. Well, if she only weighs half a pound, she's only 10 inches tall, then she just can't fit that much orange juice in the old system. So this would be 0.04 ounces. That's not very much. 2 similar American flags are 2 feet long and 6 feet long. If the area of the red fabric on the smaller flag is 124, what is the area of the red fabric on the larger one? Well, obviously we know our answer is going to be greater than 124, right? Because this is on the small flag and we want to know what's on the big one. So this right here gives us our K value. So we're going to go from the smaller to the bigger. So we'll take K is 6/2, which is 3. That's our K value. Now we're talking area, so that's K squared. So K squared is 9, right? 3 squared is 9. So we're going to take that 124 and we're going to multiply it by 9, K squared. And that gives us 1,116 square inches. All right, 16-inch pizza is $13.50. How much would should a 10-inch pizza cost? So K here, so we're going to go from the bigger cost to the smaller cost. So our answer is going to be less than $13.50. Right? Our 16-inch pizza is going to cost more. So our K value is 10 over 16. So that's 5/8. So here I did 6 over 2 because I was going to go from the smaller flag to the bigger flag. So I want my K value to be bigger than 1, so the number gets bigger. Here I'm going from the bigger pizza to the smaller pizza, so I want my K value to be less than 1, so my number's smaller. So now I'm going to take my 1350. Now remember, this is K squared because we're talking about the area, right? The cost of the pizza is based on its area. So we get $5.27. Don't make the mistake of trying to do a proportion. I know some are going to be like, oh, 10 over 16 equals X over 1350, and this is totally wrong because they're not in the same dimension. This is a one-dimensional measurement. This is a two-dimensional measurement. You can't do proportions over dimensions. If an 8-inch pizza serves 2 people, how much can be served from a 16-inch pizza? So we're going from the smaller to the bigger. So we know we need more than 2 people. So our answer is going to be bigger than 2. So we're going to take 16 over 8. That's our K value. So that's 2. And because it's area again, we're going to take 2, the number of people, times our K value squared. And that's going to give us 8. 2 squared is 4, 2 times, 8 people. All right. 2 similar storage sheds are 3.8 and 5.6 meters tall. If the material for a new roof of the smaller shed is $850, what does the material for a new roof on the larger one cost? So we know our answer is going to be more than $850 because we're building the roof for the larger shed. So we're told how tall they are. So our K value is 5.6 over 3.8. Now, because we're talking about a roof, that's surface area. So we got to take our 850, multiply it by our K value squared. And I did something wrong. Oh, I did the see, I flipped it. Sorry about that. Okay, $1,845.98. So when I saw that my answer when I typed it in the wrong way was less than $850, I was like, okay, I must have done something wrong because it can't cost less to do the bigger shed. All right, the exhaust fan for the larger one moves twice as much air as the fan for the smaller one. Will it do a good job ventilating the shed? Explain your answer. All right, so this is a volume question, right? How much air is contained is a volume question. So let's find the K cubed value. So K cubed is 5.6 over 3.8 cubed. All right, so that's about 3.2. So that means the volume of our bigger shed is over 3 times as big as the volume of the smaller shed. So if you get a fan that moves twice as much air, that's not going to ventilate as well because it's needs to move 3 times as much air. So you would need a fan that moves over 3 times as much air per minute to do just as good a job. All right, Gil made a solid model of a volcano out of paper mache. Used 8 sheets of newspaper for the paper mache. Now he wants to make a similar volcano twice as tall. So that my K value there is 2, because height is one-dimensional. How many sheets of newspaper will he need? Well, this is surface area, right? When you make paper mache, it's on the outside, it's surface area. So 8 times my K value squared. So 32 sheets. And then how will the area of the bases of the 2 volcanoes compare? Well, that's just your K squared value, right? So K squared was 4. So the base, which is area, is 4 times as big if they're similar. All right, Mr. Crane picked 2 pumpkins from his garden. They appear to be similar. The larger one weighed 16 pounds, the smaller one weighed 2 pounds. What's the ratio of their diameters? Now, this is tricky because they give you weight. Weight is 3-dimensional. So K cubed is 16 over 2, 8. And we want to know the ratio of their diameters. That's K, right? So we got to take the cube root of 8, which is 2. So the larger pumpkin will have twice the diameter. So the ratio is 2 to 1. 2 aluminum cans are similar. They're large. The larger one uses 1.8 times the aluminum as the smaller. If the larger one holds 48, what's the capacity of the smaller? So this is, now they're giving you the K squared value. They're giving you surface area. So K squared is 1.8, right? So if the larger one holds 48, so now we got to take 40, what's the smaller? So here's the difficulty. If we just took 48, capacity is volume. So this problem's really tricky. So because we're going from the larger can to the smaller, I'm going to write my K squared value as 1 over 1.8. Because I know when I go from the bigger to the smaller, my number has to get smaller. So K squared is 0.5 repeating. That's 5/9, I believe. So K squared's 5/9, but I want my K cubed value. So how do I go from K squared to K cubed? Well, the way that you would know how to do it is to first take the square root. So that will give us K. So K is 0.745. And then I'm going to cube it. Notice I'm not rounding right now. I'm just using the answer in my calculator so I don't have any rounding error. So K cubed is 0.414. Now, because this is less than 1, that's going to give me a smaller answer. So now I can take 48 times my K cubed value, and I get 19.88 ounces for the capacity. So that was really hard. So if you got that one right, awesome, good job. If you didn't get that one right, hopefully you understand how to do it now. Number 10, the area of 2 similar ice skating rinks are 1,200 feet and 1,728 feet. The fence surrounding each is the same height. If it takes 9 gallons of paint to paint the fence around the smaller rink, how much is needed? Well, so we know our answer is going to be bigger than 9 because it took 9 for the smaller fence. Now, all right, so I just realized that my video cut out. And anyway, so I didn't realize that some of the stuff got cut off that I was doing. been battling technology quite a bit today. Anyway, the answer for number 10, so I know the answer is going to be bigger than 9 gallons. And the tricky part is you might see gallons here and think I need my K cubed value because it's gallons. But the really, really tricky part, and this question is really not fair. The tricky part is that it tells you the fence has the same height. So it's not the fences themselves that you're painting, the rinks are similar, but the fence, what you're painting, is not similar because the heights aren't in proportion the same way that the length of the fence is. Obviously, you need a longer fence to go around a bigger rink, but if the height of the fence is staying the same, then you're not going to be, your fence is not similar. So what we're really looking at here is just, so let me just explain it this way. Let's say 1 gallon of paint covers about 400 square feet of fence. Okay, so we have 9 gallons of paint. That would be 3,600 square feet of fence I can cover. Now, I know the fence doesn't say, let's just say the fence is 8 foot high. So where did I get that from? I'm just saying, if you wanted a privacy fence around your pool, let's say it's 8 foot high. So then the length of your fence, or the circumference, it may not be circumference because a rink, sorry, this is an ice skating rink, not a swimming pool. Sorry. So maybe you want an 8 foot fence to keep the puck if you play hockey on it. Anyway, so let's say you have an 8 foot high fence. So it's not really circumference because rinks are not circles. But if we look at the perimeter, or the length of your fence, we'll call it length, is 450 feet. Because if you just, imagine that you just cut the fence and could lay it flat across the ground, like if you, don't really have a good example here. So, if this is not working very well. Okay, so just imagine like this is my fence here, all the way around like this, right? And if I just could lay the fence out flat, you're just going to get, a straight line with however tall your fence is. So, if this is my 8 foot tall, and then this would be my 450 feet around, gives you just a rectangle that's 8 by 450. Well, so if it takes my 9 gallons of paint to cover this area, assuming we only paint 1 coat, now if my height has to stay the same, it's only my length, which is one-dimensional, that's going to get bigger to go around this fence. Sorry, to go around this rink. So if I take 450 times 1.2, my K value, then my new length is going to be 540 feet, but it's still only 8 foot tall. The height stays the same. So 540 times 8 is 4,320. If I divide that by 400 square feet per gallon, I get 10.8 gallons. The other way you can do that is you can say, so I kind of did it a long way to try to help you understand. If you did 9 times 1.2, that's 10.8, right? So 9 gallons times my K value is 10.8. But this, not a good question in my opinion. This one, they give you gallons. So K cubed is 8 because 1,200 gallons to fill up the pool. Oh, double the radius. So k is 2, but we want k cubed because it's volume. So k cubed is 8. 8 times 1200 is 9600. And this one, they give you a volume of 2. What factor should each dimension be multiplied to make a similar crate with a volume of 54? So I did 54 over 2 is 27. That's my k cubed value. And then take the square root, you get 3. So each dimension should be multiplied by 3. And this bottom part's just review. And so you should be able to handle that. So hopefully that helps.